So today we are going to wrap up section 5.6. Our goal in this section has been solving quadratic equations using the square root method, where we're taking the square root of both sides after isolating the x squared. So our goal is to isolate the x squared and then take the square root of both sides so that we can solve for x. We're going to look at an application today. Remember, an application is a word problem. And this word problem deals with objects that are falling from some sort of height or location above the ground. And this is in your notes packet. It is on page 55 of your packet, your chapter 5 packet. Please make sure that you are taking notes and following along through the problems as we work through them. The important thing is that you are completing the problems as we are doing them as the notes together, using the steps that we've talked about throughout the entire year. So I should see that process of solving an equation by getting a variable by itself. So I want to make sure we're using the process that we've discussed throughout the year. So this skydiving problem, I've never been skydiving, and it's not something that really interests me, but I have a best friend who did go skydiving when she was in college. That was something that she decided to do. So we have a skydiver jumps from an airplane that is 6,000 feet above the ground. Now, if you're typically flying in an airplane, maybe going to Florida or going to California or wherever you happen to be going, usually the airplane is around 35,000 feet above the ground. So this is 6,000 feet. So it really isn't that far. It's actually a little more than a mile above the ground. So 6,000 feet above the ground. The skydiver opens her parachute when she is 2,500 feet above the ground. So we want to write an equation that gives the height in feet of the skydiver above the ground as a function of time. And I'm going to give you a little formula. This is called our falling objects model, because something is falling from the sky or from up above. So there's an equation that we're going to use, and we're going to plug stuff into the equation. But the basic equation for the falling object is h equals negative 16t squared plus h sub 0. I'm going to tell you what that information represents. So this h is our end height. T squared represents our time. And then the h with the little 0, that 0 represents the starting height. So we're going to see if we can use the information to write an equation for the numbers in the problem. And we're going to use this formula to help us. So the end height, if we go back and read the problem a second time, a skydiver jumps from an airplane that is 600 feet above the ground. So that's where they're starting the jump, 600 feet. The skydiver opens her parachute when she is 2,500 feet above the ground. So she's falling to 2,500 feet and then she opens her parachute. The question says, write an equation that gives the height of the skydiver above the ground. So her end height is when she opens her parachute, and that's 2,500. So that goes in for h. That's what our problem is equal to, her end height. The negative 16, that number is there because of gravity. There's gravity on Earth that kind of pulls us to the ground, and because it's negative because we're falling towards the ground. So that's why it's a negative, because we're going down instead of up. And then the initial height, or the starting height, the original height. Well, they jumped out of the plane at 600 or 6,000 feet, so we're going to plug that in. So this is our equation for the object that is falling. In this case, it's the skydiver. So then for part B, how many seconds does the skydiver fall before opening her parachute? We are going to use this equation that we just created from part A. And we are going to solve the equation for t, because we want to find how many seconds, and seconds represents time. So now this is where we have to use the process that we've just kind of discussed all year. How do we get a variable by itself? And the first thing we need to do is move the 600, or 6,000, I'm sorry. So to move the 6,000, we have to subtract it. I need to see that step, the thing that you're doing to both sides of the equation. So if we take 2,500, use your calculator, minus 6,000, you get negative 3,500 equals negative 16t squared. That cancels out. The next step, we have to still get t by itself, and there's a number in front that we need to divide by. So divide by negative 16. So the negative 16 cancels. That gets t squared by itself. In your calculator, you're going to take negative 3,500 divided by negative 16. And it's okay that it's a decimal this time. It's a word problem, so we're going to make it a decimal instead of keeping it exact. So 218.75. So word problems, we use decimals because we're trying to find out how many seconds. So now the t squared is isolated. This is where we take that square root of both sides of the equation because our goal is to just get t, and by taking the square root, those cancel. And again, in your calculator, we're not trying to find a perfect square. We're actually going to use a decimal. This is the only time you're using a decimal. So you're using the square root, second x squared, 218.75, and place that in your calculator. And I have 14.79. Now usually we put a plus or minus sign in front when we're solving. We do not do that in this case because time is positive, time is not negative. But we have to remember to label our variable, and the question said how many seconds, so we're going to label that with seconds. So she is going to free fall, that's what it's called, about 15 seconds from 6,000 feet to 2,500 feet. And then she'll open her parachute, and then the parachute will kind of glide her down the rest of the time. So 15 seconds free falling, dropping in the air from the plane. That's pretty crazy. So that would be our falling object model. Underneath, we have a couple little equations here. And we can go through these. I'm going to go through them pretty quickly. Again, we're using that process of trying to get the variable by itself that we worked with all year. So see if you can do these on your own. Taking the 7 to the other side. I want to see that, subtracting 7 to the other side. Dividing by 3. Use your calculator if you need to. So a variable is isolated. Take the square root of both sides. Square root of 16 is a nice number of 4. And then the last step is to put the plus or minus in front. So a plus or a minus. So x equals plus or minus 4. Next one, we got to take that 10 to the other side. We have to add 10. So that gives us 35. Trying to isolate that variable. Divide by the number in front. 35 divided by 7 is 5. And then finally take the square root of both sides. 5 cannot be broken down. Only numbers that make 5 are a 1 and a 5. So we just keep that as a plus and minus, and then the square root of 5. Remember that plus or minus is in every answer that isn't a word problem. And these should all be exact, like the square root of 5. Only time decimals go are when we have word problems. All right, the last one has parentheses. So we're going to still work through this the same way. We are going to divide by 2 first because that's in front of the parentheses. We keep the parentheses. We're not getting rid of them. This one's slightly different. 32 divided by 2 is 16. All right, the next thing we have to do here is get rid of the thing that's squared. So the parentheses are still here. We're taking the square root of both sides. By doing that, the square and the square root cancel, and we have x plus 5. The square root of 16 is 4. Every time we take a square root, we use a plus and a minus in front. Now this problem is a little different because there were parentheses. This is the problem that we split into two little equations. One equation is x plus 5 equals 4. The other equation is x plus 5 equals negative 4. So a little different than the other two because there's parentheses. So parentheses means we solve the problem differently. Now I have two equations that we need to use to solve for x, and we're going to get x by itself. So I would subtract 5 from both sides. 4 minus 5 is negative 1. I'm going to do the same thing, subtract 5. Negative 4 minus 5 is negative 9. So you can see that this answer looks different from the others because they're two different answers, and that happens because of the parentheses. So I'm going to end this video, and then I'm going to post a second video with the worksheet that you have for homework, and I'm going to just work through a couple of problems in that video that correspond with the worksheet.